In this video, we will be discussing the procedure for converting the regular expression to DFA using a direct method. The algorithm takes the regular expression R as input and gives DFA D that recognizes the language represented by R as its output. The steps for converting the regular expression to DFA are: the first step is to augment the given regular expression into R followed by hash. The need for converting it into augmented regular expression is to make the last state of the regular expression into an important state. The second step is to construct the syntax tree T for the augmented regular expression. Then the third step is to give a unique integer for each non-epsilon labeled leaf node. Then using the syntax tree, we need to compute the nullable, first position, last position and follow position for each and every node of the syntax tree. Then finally construct the DFA D using these functions which we have computed. Now we will see the functions that should be computed using the syntax tree. First is nullable. Nullable represents true or false for every node. So the nullable for a node will be true if it is possible for that node to be null. That is, if the sub-expression represented by that node n has epsilon in its language, then the node will be true. Otherwise, it will be false. Then first position. First position of a node n is the set of positions in the subtree rooted at n that corresponds to the first symbol of at least one string in the language of the sub-expression rooted at n. That is, it will represent all the possible first positions that can occur at the node n. Similarly, the last position of a node n is the set of all positions that can come at the end of the node for that subtree. And finally, we need to calculate the follow position of every I. Follow position is the set of positions that can follow position I in functions. So the rules for computing the nullable: for a node which is, or for a leaf labeled as epsilon, it will be always true because it is null node. A leaf with a position I will have false because it cannot be null. It represents some symbol A or B or 0 or 1. Any node with an operator R. So if a node n is having an operator R and the left child and right child are C1 and C2, then the nullable for that node n is computed as nullable of C1 or nullable of C2. And nullable for a node with a concatenation operation is computed as nullable of C1 and nullable of C2. That is, only if two nodes are null, C1 and C2 are null, then n can be null. Then for a node which represents C star, which is your clean closure, it is always true because it is 0 or more times. The operator is 0 or more times. So there is always a possibility of 0 times. So it will be always equal to true. Next we will see the rules for computing the first position. First position of a leaf labeled epsilon will always be 5. That is an empty set. And a leaf labeled with an integer I will be that integer I. Then first position for a node with an OR operator will be the union of first position of C1 and first position of C2. That is, n can have the string either from C1 or C2. So the possible first positions of the node n will be taken either from C1 or C2. So it will be union. Next we will compute the first position of a node represented by the concatenation operation. So to calculate the first position of the dot node, we need to take the nullable of the first child of the dot node. So if the nullable of the first child is true, that means C1 can be null. So the possible strings can either come from C1 or it can come from C2. So the first position of that node n will be the union of first position of C1 and C2. Suppose nullable of that first child C1 is false, then it will be always C1 followed by C2. So first position of the node n will be equal to first position of C1. Similarly, for the clean closure operation, it is repeatedly the same substring. So the first position will be the same as that of the substring. So first position of n will be equal to first position of C1. Similarly, we will calculate the last position of a node. So last position of a leaf node will be labeled as epsilon will be null, then labeled as I will have I, then last position of a node with OR operator will be union of C1 union C2, because it can come either as n can be either C1 or C2. So last position can come either from C1 or C2. Then if it is a concatenation operation, C1 dot C2, now the last position you have to compute using the nullable of the second child C2. So if C2's nullable is true, then it can either come from C1 or C2. So last position of C1 union last position of C2. Suppose nullable of the second child C2 is false, then last position of n will be equal to last position of C2. Then for clean closure, last position of n will be last position of C1. So they are similar to as the first position. Next we will compute the follow position. Follow position will be computed only for two nodes. One is the cat node and the other one is the star node. So we will use the two rules. First rule is for the cat node. So from the diagram you can see for a cat node, the first child is C1, second child is C2. So for every node we have already computed the first position and last position. So if you see the diagram, the last position of C1 is followed by the first position of C2. So the rule is for every position I in last position of C1, then all positions in first position of C2 are in follow position I. Similarly, for the star node, it is the same node repeated again and again. So we will have the first position of n and the last position of n. So it will be the same thing again repeated. So for a star node, the rule is if I is a position in the last position n, then all positions in the first position of n are in follow position of I. The next step is to construct the DFA states. So once all the functions are computed, now we have to start with S0, which will be the first position of root, where root is the root of the syntax tree. So take that S0 as the DFA state and take it as an unmarked state. Now you have to repeat the following procedure for all unmarked states in D states. Now we have taken S0 and we have marked it as T, and for every input symbol in the given regular expression you have to do the or calculate the transitions. So let us take the input symbol A. So for the input symbol A, you need to find out the positions which are representing A in the given state T, and find out the follow position of all those positions. So positions that are in follow position P, you have to take it as an union and you represent it as U. Now if U is not empty and if U is a new state which is not already available in D states, then add that U state, new state U into the D states. Then fill the transition DFA transition table for the new transition that we have calculated. So d tran of t comma the input symbol a will be equal to u. Now you have to find out the transition for all the given input symbols for the marked state t. Now after computing this, then take the next state which is not marked and take it as t and repeat the procedure until you have found all possible transitions and until there are no new states which are available in these states. Now once you have computed, you will have a complete DFA transition table, and using this DFA transition table you can draw the DFA diagram. Now we will see an example for a simple regular expression epsilon or a concatenated with b star, the whole star concatenated with the hash symbol for augmented regular expression. So after augmenting, you have to draw the syntax tree. To draw the syntax tree, you have to apply the operator precedence. So in the operators that we will usually use in the regular expression, asterisk or your clean closure has the highest precedence, which is the unary operator, followed by the concatenation or cat operation. Then the least priority or precedence will be given to the OR operator. In addition, you have the parenthesis which can overcome all these precedence operators, and parenthesis will have the highest priority or precedence. Now in the given regular expression, epsilon or a is in the innermost parenthesis and that has the highest precedence, and followed by b star, and then that b star sub expression is concatenated with the epsilon or a, which in turn has the whole star operator, and then you have a concatenation operation. So using the operator precedence, if we have to first construct the syntax tree for epsilon or a. Then after the construction of the nodes, so epsilon will be a leaf node, a will be a leaf node, and r will be an interior node which contains epsilon and a as its child node. Now construct a leaf with b and the operator as star, because that is the next precedence. Then it is concatenated with the already given expression. So the next node is dot operation. Then the whole node is parenthesized to a star operator, so star, then followed by the concatenation to the augmented symbol hash. So we have completed the syntax tree using the precedence of operators. Now after the syntax tree is completed, the next step is you have to number all non-epsilon leaf nodes. So A is numbered as 1, B will be numbered as 2, and the hash symbol is numbered as 3. After the nodes are numbered, the next step is to compute the functions nullable, first position, last position, and follow position. So first we will compute the nullable. So nullable for a leaf with epsilon is true. Then for a leaf which is numbered as 1, it is false. And for the leaf which is numbered as 2, it is again false. Then if it is a star node, it is always true. Then if it is for the OR operator, you have to take the OR operator of the child. So true or false, it is true. Then for cat operation, it is AND. So true and true, it is true. Then for star operator, it is always true. Then for the node numbered as 3, it is always false. Then the cat operation, so it is T and F, so it will be F. So the nullable for all the nodes have been computed. Now we will compute the first position for each and every node in the syntax tree. So for the node which is labeled as epsilon, it will be null, that is 5. And for all the other leaves which are given an I, it will be that number. So for A it is 1, for B it is 2, and for hash it is 3. Then for interior nodes, R node, it is union of null and 1, so it is 1. Then for star node, it will be the same as that of the child, so the first position will be 2. Then for dot node, we need to take the nullable of the first child, so it is true, so it will be union of 1 union 2, so it is 1 comma 2. Then for the star node, it will be same as the child node, so it is 1 comma 2. Then for the concatenated node, that is the root node, it will be, you have to check the nullable of the child, first child. So since it is true, it is union 1, 2, 3. After computing the first position, the next step is to compute the last position. Similarly for all the nodes. Same way, for a leaf node with epsilon, it will be a phi or null set. Then for all leaf nodes which are numbered, it will be 1, 2 and 3. Then for the interior nodes, we need to take, so this is, you have to take the nullable of the second child. Since it is false, it will be taken as such. Nullable for star node, last position of star node will be same as child. Then for concatenation, you have to check the nullable of the child node 2. So since it is true, you have to take union. For star node, again it is the same. Then for the concatenation operation of the root, check the nullable of the second child. Since it is false, you have to take only that of the second child. So nullable of the C2 will be the nullable of the root, which is 3. Now once you have computed nullable first position and last position for all the nodes, next we need to compute the follow position, which will be calculated only for the star node and cat nodes. So for the star node, 2 is the first position and 2 is the last position. So 2 is followed by 2, so include 2 as the follow position for 2 for the star operator. Next we need to compute for the next node, which is your cat node, that is your concatenation node. So for computing the concatenation node, here you can see child 1's first position, that is last position, is 1 and C2's first position is 2. So 1 is followed by 2. So for 1 you have to include 2. So that is included. Then for the next star node, it is first position and last position of the same child. So 1, 2 will, 1 will contain 1, 2 and 2 will also contain 1, 2. So it is included. Then at the end you need to compute it for the cat operator at the root. So here you can see child 1's last position is 1, 2. Child 2's first position is 3. So 1 is followed by 3 and 2 is also followed by 3. So we have computed the follow position table. So for node 1 it is 1, 2, 3 and for node 2 also it is 1, 2, 3. And for node 3 there is no follow position. So it is empty. So we have computed all. Now using this we need to compute the DFA states. So to start with, the initial state A will be taken from the first position of root. So first position of root is 1, 2, 3. So we will take it as state A, which is equal to 1, 2, 3. Now we have to take the input symbols of the given regular expression. The input symbols are A and B. Now we need to find out the transition, DFA transition from state A on input symbol A as well as input symbol B. So to find out the DFA transition, we first calculate DFA tran of A comma A from the first position 1, 2, 3. So if you take 1, 2, 3, 1 represents A, 2 represents B and 3 represents hash. So for A it will be only follow position of 1. Follow position of 1 is also equal to 1, 2, 3, which is equal to state A. Similarly, for D tran of A comma B, follow position will be follow position of D tran of A comma B will be equal to follow position of 2 because 2 represents B state. So it is again equal to 1, 2, 3, which is equal to A. So now computing, so there are no new states, so all possible transitions are completed for all input symbols. So we can fill the DFA transition table. So from state A on input symbol A and B, it goes to the next state A. So once the DFA transition table is complete, you can represent it as a DFA diagram. So A becomes the start state as well as the acceptance state. So thank you.